Welcome to the second part of the video. In this video, I'll be talking about the first and second derivatives that are used in physics, as well as finishing up optimization algorithm. So let's take a look at this table right here. As you can see, there are three terms, or otherwise known as vectors in physics. We'll be going through its definition, understanding their relationships that they have, as well as knowing what their units are. So let's start with displacement. Displacement is basically just the distance an object has moved from the original point over a period of time. The function that displacement have is actually d, which stands for displacement, and t, which stands for time. And the units that displacement have is actually in meters. Moving on to velocity, it is the rate of change of displacement with respect to time. So as you can see in this function right here, this displacement function right here, there's actually a prime written right here. So actually, if you actually did the first derivative of the displacement function, you will actually get the velocity, the function for velocity. And the units for it is in meters per second. And lastly, we have acceleration. It is basically just the rate of change of velocity with respect to time. And if you did the first derivative of the velocity function, you will get acceleration. And when you actually do the second derivative for the displacement function, you will actually get acceleration as well. So these are the relationship that all three of them hold. And the units that acceleration is written in is meters per second squared. So next, optimization algorithm. So there's in total 5 steps that you must follow if you want to do optimization algorithm. Let's start with the first one. So first off, when you want to solve a optimization problem, you will first have to write a function for the quantity you want to maximize or minimize. Second, you will have to make sure that your function has only one variable. If you try to solve a problem with two variables, it will be harder if you were to do it that way. So that's why we have to minimize it down to only one variable. Third, you have to find the first derivative of the function and make it equal to 0. Or else you wouldn't be able to solve for what is x or any variables that you have isolated. Fourth, you have to search for any other required information to solve the problem. Try not to miss out any important information such as height, length, or width. And lastly, you will have to use second derivative to actually confirm if you've found the maximum and minimum points. Okay, so let's do an example that actually involves optimization algorithm. So let's say the question asks you to find the possible max area, and you're actually given, let's say, 1200 meter worth of fencing. Okay, so the first step, as we know, is to write the function for the quantity you want to maximize. So let's write down the formula for area. So A is equals to x times y. So the second step, it asks you to make sure that your function has only one variable. So currently we have two unknowns, which is x and y, and we know that 1200 meter would be the parameter. So let's just draw it out, and so it will help us visualize better on what we're trying to actually to solve. So let's say these two left and right sides are x, and top and bottom is y. So if you wanna isolate for only one variable, we have to create another equation that may help us clear out one of these. So let's write down the function for, the formula for perimeter. So P is equals to 2x plus 2y. Okay, so now you know that your perimeter is actually 1200 meter, and you know you have two sides and two top and bottom. Okay, so let's just sub in 1200 into P. So you will have 1200 meter equals to 2x plus 2y. So in this case, you are given the choice to either solve for x or y. So let's just isolate for x. So if you want to isolate for x, you have to bring the y to the other side. So it will just become negative 2y up plus 1200. And then after that, you want to get rid of this 2, just bring it down, and you divide everything by 2. So it will become negative y plus 600. Okay, so now once you have your value for x, you just sub in into into this area equation right here. So we just write it out like this: a equals to negative y. Let's write bracket down. Negative y plus 600. 600 multiplied by y. So then after that, you will have negative y square plus 600y. Okay, so let me just create a new page. Negative y square plus 600y, new page. Don't save. Okay. So we now know that a is actually equals to negative y squared plus 600y. Okay, afterwards, you're gonna have to do the derivative of this function. So when you want to do it, we'll write that down like this: a prime x equals to negative. Well, okay. So if you want to do derivative, we wouldn't actually have to use the rate of change formula or the limit formula. We could just do this. As you can see, that this is actually y squared, and it has a power of 2. We can actually bring this number down in front of the y, write it down like this, and minus 1 from this value. So this will just become 2y to the power of 1, which is just negative 2y. And since you see this one, this 600 right here, there is no power or exponent. So when you minus 1 by 1, it will just become 0, right? So if let's say you have a variable or a number that is to the power of 0, it will just become 1. So this y will just be 1 and you'll just have 600. Okay, once you have this, you have to make it equal to 0. Let's not forget that. Okay, once you've done this, you have to isolate for y now. So when you isolate for it, it will actually become 2y equals to 600. And you know that your y is equals to 300. So now we know what our value for y is, but we haven't figured out what is our value for x. And if you remember, our x is actually equal to negative y plus 600. So we can just actually sub in this y value of 300 in here and then solve for x. So this will become negative 300 plus 600, which would just become 300. Okay, so now we know both of our variables and their values. We can just sub it back into the area equation, which is a equals to x times y. So if, let's do this, a equals to x multiplied by y, and we know that it's actually equals to 300 multiplied by 300, we will actually get 90,000. 90, oh, let me just write it on here. Will equal to 90,000. 90,000 meters square. So that is actually how you can use optimization algorithm to solve for optimization problems.